In this lecture, we'll take up the detailing of stairs. So, in case of detailing of stairs, you have two different types of stairs here, what are specified in SP34 or what we may have in our construction. So, the first one is the stairs which are supported at the ends of their landings. You can see this is the support, what is shown here. So, the stairs have been supported at the ends of the landings. Okay, here at the end of the landing, this is the support, what is shown. This is one type. The other one is where the stairs are supported at the end of their flights. So the flight is ending over here, and this is the support, and here also at the end of the flight. Okay, so we shall go ahead with this first one. Stairs supported at the end of the landing, and you can see here the reinforcements what are shown. This bottom steel will be the reinforcement in the waist slab. That is the main reinforcement, and over this we'll be having the distribution steel provided here, and this is the main steel what is will be provided for the landing slab main reinforcement. It is also on bottom side. Okay, now these reinforcement, okay, when they when they come when you come across this junction between the waist slab and the landing slab over here, this is how the reinforcement will be crossing each other. Okay, so this landing slab reinforcement will be taken till the top of the landing slab. The waist slab reinforcement, what you see here, that will be taken up to the top of this landing slab, and then it will be bent in, and it will continue into this landing slab. And this main reinforcement, which is provided in the landing slab, will be taken up to the front side of these waist slab or towards the steps. Then it will be continued for a length of development length. This is ELD, for length equal to development length, measured from the junction of landing slab and waist slab at this point. In no case, you have to bend the reinforcement over here. That is the important thing what you need to take care. Say this is our landing slab, and this is the waist slab. The reinforcement should never be bent at this point. This is the wrong thing what we follow here. So it has to be taken till the front face. This will avoid the pressure on the concrete in this region, or that will also prevent the spalling of the concrete or the cracking of the concrete at this junction. So that is the reason why this will be extended till the front of this waist slab. So if this is the reinforcement in this landing slab, it shall be taken up to this front face, then it will bend over here, not exactly at this point. Okay, so this is how you need to follow there. So that is one thing, and also we can look at the details of reinforcement at the ground level. So what you have is here, this is the plinth level. The waist slab will be connected to the footing over here. There may be a plinth beam in some cases, but if at all the footing is there, so the reinforcement in the waist slab will continue into this footing, and it will be connected with the bars which are provided within the footing, the starter bars of the footing over here. Okay, so this is the details at the base. Okay, same in case of the next flight, a flight will be followed here. Waist slab reinforcement and the landing slab reinforcement, main reinforcement have been shown, and their details at this junction. Okay, so this bar or the reinforcement of the landing slab will extend into the flight for a length equal to development length here also. And these reinforcements are for the steps. They may be provided, they may not be provided. If required, they will be provided, or probably the steps may be a plain concrete steps also. This is the reinforcement for nosing that may be provided. In case if you are given the details, this should be shown here. Or sometimes they may construct brick masonry steps like this. These are details of the steps over here at the section X. Details at the section with brick steps, and the same details of the section with nosing reinforcement. Okay, or we may have plain concrete steps also. Instead of brick, you'll come across plain concrete being poured over here. And these are the chairs what we have. They will provide support for this top reinforcement to hold it in position. So let's go with our problem. Uh, this is the problem what we'll be taking up for detailing. So prepare the details of reinforcement for a dogleg staircase. Given the floor to floor height is 3.3 meter, staircase hall is of 5.5 meter by 3.6 meter. Risers are 150 mm and tread are 250 mm. Thickness of base slab, floor slab and the landing slab is 150 mm. Details of reinforcement. Base slab, the main reinforcement is of 12 mm dia at 125 mm center to center, and the distribution is steel is 10 mm dia at 150 mm center to center. Width of landing, let me not provide this. We'll go for calculating that since staircase hall is given us to us. So materials are M20 and Fe415 grade steel. Okay, so first is we'll decide what number of steps will come. We'll go for a dog leg stair. For a dog leg stair, it is asked for a dog leg stairs. Okay, so the floor to floor height. The floor to floor height is 3,300 mm. Okay, so number of steps, or you can also call it as risers. Number of steps or number of risers shall be equal to this 3,300 by 150. So this will be 22 numbers. Total steps are 22 numbers. That comes out to 22 numbers. Okay, so there will be 11 in each flight. So dog-legged stair, two flights will be there. So we'll be providing 11 steps in each of the flight. 11. Okay, and now what will be the number of treads? So number of treads will be 11 minus 1, 1 less than the number of risers, which will come out to 10 numbers. Okay, and length of going shall be equal to 10 into the tread size, that is 250. So this will be 2500 mm. Okay, this is our length of going, the horizontal length of the flight. Then width of the flight. Okay, so the width of the flight shall be half the width of the staircase hall, which will be 3.6 by 2, 1.8 meter, and width of landing slab will also be equal to width of flight. It should be at least equal to width of the flight, so the same minimum value I have taken here, so 1.8 meter. And let us go with the plan. What we'll have here is All right, so first thing is the plan of the stair hall. We can prepare this plan. So what we are given with is, what is the size of this staircase room, and this is the staircase hall. So clear size of the staircase hall, we'll take it what is given over here. So in this distance what we have is 5.5 meter. Okay, so 5.5 meter, and this is 3.6 meters. So that is the width of the staircase room, and within this we'll be having the staircase. This will be the opening for the staircase hall. Okay. Anyhow, we'll draw it in the AutoCAD. So first is landing. Okay, so this will be 1.8 meter. Okay, and the staircase, 2 flights. So they will be 1.8, 1.8 each. So this is the 2 flights, and what we have here will be the space available at the entrance. Okay, so this is staircase hall. So as per our calculation, out of 5.5, what I have here is 1.8 meter. Okay, and this is 2.5 meter, 2.5 meters. Okay, and this will be how much? 5.5 is the total size. 5.5 minus 2.5 minus 1.8. It is 1.2 meter. What is left over here is, this is the space which is available at the entrance. Somewhere here the door will be there. Okay, or the opening entrance for the staircase hall, and these will be the steps. Okay, so this is our plan of the staircase hall, and the same what you need to do is prepare the AutoCAD drawing, and along with this also what you have to do, prepare the sectional elevation. So plan at level. In one of the flight you'll be able to see the steps. So whatever number of steps required, that has to be drawn in the AutoCAD here. So this we can say the plan. So this is how you enter the staircase. This will take you to the next floor. Okay, let's move to the AutoCAD with this all sizes and dimension. So first here, what I'll do, I'll take up the plan. Okay, so rectangle for that one, 0, 0, first corner. The next corner will be 5500 5500 meter in length and 3600 width. So this is the staircase hall, and fine. Offset by 0.23, that will be the wall thickness what I am considering, sorry, 230 mm. Offset offset 230. So this I'll offset by 230. So this is the staircase hall. Now what I'll do, I'll mark this two flights. Okay, this we shall explore this one. Okay, and then again offset landing slab 1800 here. So this is the landing slab, and offset 1200 on this side. So this is our entrance trim. Take this out. Okay, and on one of the flight I'll show the steps. Again offset, tread is of 250 mm. So I need 9, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So these are the trips. For the next flight, which will be, since section will be taken at the cell level, we'll just show them by a copy. So copy, paste here. Okay. So these shall be shown by a discontinuous line. They are hidden edges which are not appearing in the. Okay, this is the staircase hall plan, and somewhere over here, so let's say 1200 1.2 meter is our door size. So that is the door entrance. Okay, and also I need to hatch this brick masonry wall. Points here. So scale will make it as 50. Okay. Right. Now we'll move on to the elevation part. So for elevation, I need to start with this one. My reference, and this is where the staircase will start. This is where it will end. Right. to the end of the staircase. Okay, so in each flight, what I have is 10 steps. So 10 into 150, 1.5 meter. This is 1500. Okay, and from here this will be going to the landing, and this will be our waste slab, bottom portion of the waste slab. Okay, and the first step what I have 150. Every step is of 150. Okay, then 250 and 150, 250, 150, 250, 150, so on. 250 again, riser 150, this is 250 tread. This is 150, the step, last one, and 250, which will merge with the lining slab. Okay, so this is one of the flight what we have, and this should be offset now. Offset, and offset distance is 150 because base slab thickness is 150 here. So this is the offset. Okay, and we'll trim off these excess edges. Okay, I don't need this anymore, and this will be the landing slab. Just to check the dimension of this landing slab, how much is it? 1800. Okay, so this is the first flight. Now with this we'll go for the detailing part. So what I need to do is show the reinforcement in the waist slab. I'll offset this one by 25, taking 25 as my cover. Okay, so this is the reinforcement in waist slab. Okay, so on the top portion it has to extend up to this top of the landing slab, or extend right, and take out this same waist slab reinforcement 25 mm. Take this one and offset this one. Okay, then just go for extending this. Okay, and from this point Okay, so as I told, these reinforcement we shall show them by a thick line. So I'll increase its line weightage by 0.25. Okay, and this is it. Then coming to the foundation. So here I'll be taking the foundation. Let's say about 3003 approximately. So this will come at the bottom. Okay, let us remove these lines entirely. Typically, this will be the foundation what we have. So I just take it below by say 500 mm. Okay, say this will be around 300 and 300 again. So plinth level. Okay, it would have been here itself. So this is the details of the foundation what we have here, what we have shown. We don't have any particular details of the reinforcement in the foundation. These are just to show that this is how the foundation will merge with the staircase. The top parts here. So landing slab bar will continue. Okay, and so the this top bar, okay, to take up any negative movement in case if it is arising. That is the additional bar what is being provided here. This we shall stop at here only after development length. Yes, this will stop at this point. Okay. Radius and 50. So this is that U bar. Okay, and okay. This is enough for that steel. Okay, that will be a typical thing that will over there. So footing. So that is the details what you have in the footing. Bar weightage. Okay, and what we need to show here is the distribution steel for this. So distribution steel, taking this donut in a diameter 0, outer diameter 10, if we keep it. So let's start at this point over here, right? So this will be provided at distribution steel is provided at 150 mm center to center. So okay, I need to extend the distribution bars along this base slab reinforcement. So best way is to take this array. Okay, so I specified columns as 40, or let us take 30, and 150 mm center to center is the spacing. So we'll take it along this inclined bar. Okay, this is my first point to choose the angle, and one point somewhere on this bar. Okay, so they have been provided here. So these additional I have specified just 30, so they are moving outside this. So we'll take them out. This one will place it somewhere below over here. This is it. Then again for the slab, we'll choose it as 10. Okay, 0. Choose that one. Right. This will stop it. We'll offset through 150. Just one or two objects. Okay. Copy. Center point. Auto on 150, 300, 450. That should be enough. Okay. So this is sufficient. Okay, so same thing, we'll copy it for the bottom one. That is for the landing slab reinforcement. Okay. Same array. This will be minus 150. And then copy this one. Yes. And here these bars should appear on the bottom side. Copy them. Okay. This is the steel distribution steel. Okay, that is the staircase details. For one more flight, what I do is I just choose this part of the staircase, excluding this foundation. So this is, I'll choose this one, okay, and I'll just copy it. Let me choose this as my base point, and I'll just copy it above and mirror this one. I have to flip it. So choosing this, okay, erase this original object, not required. So this will be the next flight what we'll be having. Okay, so this will bring it a little bit below. Okay, then I'll just over this one. So here, offset this one 150, erase this line, and extend this line up to here. Extend waist slab bottom till here. Okay. That is for the next slab flight. What I'm doing over here. Okay, just copy this. I should flip this also. Okay, that may not be necessary. That is not required. We skip that. So this is the reinforcement of top slab, which will be coming inside. So they are mentioned here, top reinforcement if required from bending moment consideration. If at all if the slab is subjected to any hogging moment due to the second flight, then we can have it. If it is given as per the design, we can provide it or else not required. This will have to be changed. So 150 points on this line. Okay, and then further offset to not offset, multiple copy, center, and this direction 150, 300, 450, 600, I think 750. 1050, 050, 1200. Yes, this is our second flight. So this is the details of reinforcement. So one more thing that is required is detailing. So I choose this one, and this is my main reinforcement, which is 12. Uh, let's keep it Y12 at 125 center to center. Okay, this font size can be increased. Okay, and distribution steel what we have, just copy this one itself. This is the distribution steel. So for this it is 10. Okay, it is just required to change the font size and dimensioning base slab thickness. Okay, I should take alignment. So this one, right, 150. And also tread, specify the tread and the riser. Right, so voice slab can give it here. One more thing what is to be shown is the masonry wall which will be coming here. This is the brick masonry wall. Offset this 230. Yes. Slab has to extend inside this brick masonry wall. Okay. And same details are there for the lining slab also. That is says says and distribution steel. Oh, Okay, so this will be the staircase details. You need to prepare the plan as well as the sectional elevation. So this is the landing slab width and the size of the staircase hall, clear dimensions of the room, length, and this is the width and wall thickness. So one more here, the dimension of this opening. So this is the opening size and direction. Okay, so these two have to be prepared and also the detailing has to be done for the same. I'll also show this width of the flight. Option style, okay. Done.